Hello everyone, this is Anshka Gupta and welcome to my channel Let's Code and Solve by Newton School. Today we're going to study about what are Pareto distribution. Before going to that, let's know what is Newton School. So Newton School is a platform which prepares you for career in tech. It has courses designed for freshers, working professionals and also for women with non-tech background. Newton School first trains you for 6 months and helps you to become amazing full stack developer. It also has a network of more than 300 great companies who hires from Newton School. So once the training is completed, Newton School also ensures that the students are placed with some of the best companies in the country. And the best part is the Newton School has a pay after placement program under which you don't have to pay Newton School anything until or unless you have been placed with minimum 5 lakh CTC. Let's go through the Newton School website. Here you can log in and sign up yourself. Top companies in which you have been placed is Rapido, MyShow, Xiaomi, Lenskart, ThoughtWorks, 7-Eleven, Topper and many more. Now moving to our concept. What is Pareto analysis? So basically this is the most important distribution in your NumPy with more of the execution and more of your the language purpose in your NumPy. So what is Pareto distribution? It has been named after the Italian civil engineer. He was economist, sociologist and very more. He has a power law probability distribution to know that like how your the description of your phenomenon changes. So the analysis, when he done analysis of Pareto distribution, he saw like it has a great network of the distribution among the NumPy. So he took forward basic more ideas of what we can implement as a Pareto analysis. Originally, it is applied to describe more of your stating under the different tribability, vital roles, and many more. It also refers to the 80 to 20% rule. It is also called that. It states that 80% of the problems are or affect or comes from 20% of cause. So depends upon effect and cause. Third is it focuses on identifying the vital few and the trivial many. Okay, so that is the main focus of that. It helps us to focus upon what really matters and what actually not. So when he does the analysis of Pareto analysis, so he obtained like the exact number of percentage varies in different situations. Okay, however, most of the activity is caused by the relatively few of the factor. Here you can see the bar graph, and from the total population, the 80% has been covered with the failure or success. Okay, effect and cause. Every 80% of your effect has a cause of it. So when a Pareto distribution became a natural law, the reason for that is that Jordan Peterson starts off with the seemingly off topic, the histogram part. So it seems like it is like in association with a mathematical phenomena. The natural law of governs then like declare that it is a pattern in domains of creative human production such as farming and many. So examples of Pareto analysis is 20% of car accidents cause 80% of accidents. Okay, if there is a cause, there is an effect. Second example is 20% of the workers do 80% of the work. Third example, 20% of the company's clients are responsible for 80% of its revenue. Fourth, 20% of the time spent on a task leads to 80% of the result. Fifth, 80% of the customer complaints comes from 20% of customer. Sixth, 80% of the wealth belongs to 20% of the population. So everything has in the cause and effect both of that. 20% is a cause, 80% is the effect. And replicating to that, 20% is the effort and 80% is the result. Okay, so out of 80-20 is the conservation replications of that. Now, when the principle has been joined and the Pareto analysis and the governing power law was assigned, so it used when there are many other problems or projects that are not significant to focus on one of the more prioritized. It helps us to prioritize the most important and the improvement opportunities that brings the most value to the businesses. It also allows us to reach the consequences about what needs to be addressed first. So when the probability of measuring a particular value of some quality or quantity varies, inversely or the power of that value varies, the quantity is said to be power law in that. It also known as the zip law and the zip flow. Okay. It also used during the improvement projects to focus on the causes of the contributions and that. The Pareto chart, it has a frequency bar chart. The most common, the most frequent activities are being placed by in order to left to right. Normally, when the plots are being built upon, there is a categorical graphs between frequency and error of defect. Okay, x y axis are there between the frequencies and the effects in that or the errors in that. The historical, then the horizontal axis represent the types of activities such as issues, problems, cause. Vertical axis, any of that. It always and always represent the frequency of those activities. The Pareto analysis also help us to arrange the bars from the largest to smallest. The vital few activities can be easily addressed to have the greater attention towards that. If there is a lot of small or infrequent factors, consider adding them together into another category. You may optionally have the commutative line among the bars, or the commutative percentages can be read from the vertical axis or any of that. Here you can see the graph having the number of percentages, numbers and alphabets. So here you can change out to the 100% to the lowest and the highest part of that. You can change out how the frequency of the cumulative percentages changes out. If the resulted Pareto chart clearly illustrate a Pareto pattern, this suggests like only few causes account for about 80% of the problems are there. This means this has a Pareto effect in that. If no Pareto pattern is found, we can say that some of the factors are more important than others of that, because every time we have to check like if this factor is important or not. So how we construct a Pareto chart? For constructing that, first thing you have to remember is to define the problem. Second, you have to identify the possible causes of the problem. Third, you have to collect the record of your data. Fourth, you have to calculate the frequencies of identified causes. Fifth, draw a vertical bar for each cause or cause group. Sixth, sort them by frequency in descending order. Seventh, calculate them as in draw them as in cumulative percentage line. Seventh, if you observe a Pareto effect, focus your more of your improvement efforts. You have to get that the few factors in that. So here is an example of your Pareto analysis, how your farmers or the factory team are being doing that. That how it is being prepared by addressing the rising number of the customer complaints in the way of your management. That can be understood. The result will be can be solved by majority of the problem and concentrating a vital few of that. So let us do one program of Pareto distribution. So let us write here. Just defining it. First of all, import from numpy, import random. Okay. After that, you have to write x is equals to random, whatever the random you have mentioned. Now declaring the function here. is equals to 2. Size, any of your size you can declare as 2, 3. Okay. Now we have to print it. Printing, you just have to remember the whatever the sequences of that. So here it will be give us the values of the Pareto, that is the 1 ranging from 2, then 0, and this is the level of it, 2 to 3, area, random, and Pareto distribution in that. Okay, I hope it has been clear to you. Thank you for watching my video. Subscribe to my channel, like the video, and stay tuned.